So let's start. So our talk for today will be about designing systems for MVP. So two things, designing systems and MVPs. We will talk about designing systems not in the UI UX design sense, but more of a system architecture design and product sense. MVP, we specify that because systems evolve depending on what stage the product is. So yeah, I'm Cleo, so I'm basically here to do the talk. So thank you so much, Women Who Code Cloud, for inviting me. So just a bit of disclaimer, I'm not an expert, and most of my knowledge here comes from a practical application of systems design. So in that note, if you have a piece of suggestion or tips and tricks that you can share later on, we would love to know them when we have if we still have time for the QA. So yeah. So today we will talk about 5 parts. So where it all starts, what is MVP, the architecture design, the step-by-step approach, what's next when your MVP is a success, and key concepts on scaling. So without further ado, let's start with the first part. So we're answering the question of how in the title of my talk, right? But I think it's equally important to discuss how did we even come up with an MVP? So where does it come from? So products and services always starts with an idea. So as developers and software engineers or technology practitioners, it is our main role to turn ideas into reality in the form of products and services. So applications like Facebook, WhatsApp, Instagram, they did not start big. So they had to start somewhere and they had to start simple. And eventually they evolved into a complex app with a complex system. So talking about complex system, this is an excerpt from the Systems Bible by John Gall. So basically it says that complex systems come from simple systems that worked and actually evolved, and that in order for you, if you designed a complex system right from the start, it never works and it cannot be made to work. So you have to start and from the beginning with a simple system. And that brings us to MVPs. So when it comes to product design and development, MVP stands for minimum viable product, right? So it represents the simplest version of your product that can be released while providing meaningful value to your users. So most of the time, people associate MVPs with proof of concept, and MVPs are used to actually do the market test if users will actually use your product, if it's marketable. So the MVP approach is about learning, validating, and increasing the velocity of your product development. So the MVP approach is actually one of the recipe for success for the Silicon Valley giants. So the products, the companies that you see in Silicon Valley right now, they have their garage story, right? Like how they started everything in their garage, and they continuously iterate throughout their product so that it becomes what it is right now. So yeah, this is the recipe. So create a product, create a streamlined product based on your idea, test it with real users, get their feedback, take that feedback and incorporate it to your product. Test after you've incorporated the feedback and develop something, and then you have to test and repeat. So iteration is really the key for MVPs. So next step is let's go make an MVP. So this is the architecture design, the step-by-step approach, probably the most important part of the talk today. So, but wait, there's a word that we must think. Okay, spoiler. But wait, there's a word that we must think all the way through the design process. If we're talking about MVPs, right? And that's cost. Why? Because as we said, we have to test your product or service first before really going all out. You have to minimize your cost in order for you to answer the most important question. Does my app really work? Or is my app really usable for my users? Is it really helpful for them? So yeah, that's one word. We have to think about that all throughout the steps. So next, as a step one is requirements and specification. This is the problem statement. So what problem are you trying to solve? What inputs do you need? What tools are you going to use? And then step two is scope the problem. So for example, you're thinking of building a super app, but then the super app would take you months or even years to finish. Then you proceed with the product development, only to end up realizing that people won't even use the app. So that's very disappointing, right? And also, if someone else had thought of your idea and they chopped the features, really made a simple one, and then they launch fast, then it becomes successful. Then that would be double disappointment on you, right? So in the startup world, it's always build, launch, test, and iterate. Like in the previous slide, iteration is the key. So like a tree, you had to trim down or cut off the unnecessary branches. They're unnecessary for now, but they could be useful in the later stage of the product. So you have to determine the vital and biggest branches. Which key features matter most to your product? You have to test the main point of your idea and your product. And that is where scoping the problem. So that's step two. Step three is make assumptions, use cases, wireframes. So you have to make assumptions on your target users. Do you want your app to be used by students, or do you want it to be used by the general public? What kinds of data you'll store? Will you be using will you be getting images, PDFs, videos, or just plain data information about the user? The next would be how much data you'll store. So once you identify the kinds of data that you'll store, you need to know how much you want to store, because that is very important when you're trying to identify the memory and storage that you'll need for your servers. And another thing is your app more of input output or more on computations? That's also important because you need to identify how powerful your server will be. So in terms of virtual CPUs, how many cores do you need? So something like that. So that's step three. Step four is now more visual part. So you draw the architecture and its components. So let's say we're going to design, example is we're going to design a system architecture for an e-commerce app. Okay, so we have this very simple diagram here. So I'm going to create an e-commerce app that has an admin dashboard and an e-commerce site. So that's going to be two web applications, but they can only be in one web page, right? But they can change views depending on the user access. So if your users are the customers, then they will show you a different view. If you're going to log in as an admin, they will change also into a different view. And of course, you have a server right there. So that's where your backend logic will be. You also have a database. If you've decided it to be in MySQL, so you can use a relational database. Then you also thought that when my user registers, I want them to confirm their account. So I will be sending an email once they registered to my application. So you need an email service for that, email SMTP server. And then it's an e-commerce site, right? People buy stuff on your application. So you need payment gateways. It could be like, Stripe, PayPal, and all the whatever alternative you can think of. So this is just an example of a very simple MVP of an e-commerce app. Okay. So the next step, 4.1, is to identify the technologies and the services you'll be using. So you have the architecture already, right? But you're not labeling yet what particular technology will be used for that, and what subscriptions, what services you'll need. So I have here some of the most common things. So what you'll need, a DNS provider. So a DNS is what what your application will look like in the URL. So for example, www.myawesomeshop.com. So you actually have to buy that because when you deploy your application in a server, what the server gives is actually an IP address. So it will be very cumbersome for your user to memorize 141.162. Right? So it's better to have a DNS to mask your IP address. So that's one. You can have GoDaddy or Namecheap, whatever DNS provider you can think of. Cloud servers, very important. Database architecture and backend logic, backend and front-end technologies because we're trying to build a web app. And third-party services, like email, SMS, payments, maps, whatever you need for your app. So I have here the most common. This is not in any way sponsored, okay? I'm just giving you the most commonly used technologies, the major providers out there. So the three major providers for servers are Azure, Google Cloud, and AWS. So server instances, where you will provision the resource. There are also servers where you can just click what operating system you'll be running it with. If you want it on Ubuntu or in Microsoft environment, you can just choose on the dashboard. But some servers really require manual configuration where you have to install manually on a terminal the operating system, do the disk partitions, and install the utilities of the operating system. So yeah, that's one. And but if you want a simpler one, we have also a backend as a service technologies. They're pre-configured. You can use it right away. You just have to provision the resource. So for example, we have Firebase, right? Like if you want to use Firebase, it's already for database, they have Firestore, they have real-time DB. They have also other services like push notification. They have cloud functions if you just want to use a backend script and run it there. Just that one single function, you can use cloud functions for that one. We have also Azure App Service, and if you want to run a simple function, it's called Function Apps. And we have AWS Amplify. So yeah, this can be an option for the servers that you want to use. But there are also other providers there like DigitalOcean.
Leo?
What else? Yes?
I'm
Yes?
sorry to cut you off. We have a question in the chat.
Oh yeah, go ahead.
There's a question to elaborate on third step of the previous slide which you shared.
Thoughts on the previous slide. Let me go back to the previous slide.
Third step?
This one?
Yes, this one, yes.
Okay. Yeah, so what's the question?
So question was to elaborate on this slide. From Aram, we have that question about databases.
Okay. So actually we'll reach into that in the next slides. I have a slide for databases also, the front end technologies and the third party. So yeah, we can move through that slide later on. Okay, thank you for that question. Actually, I have prepared. So yeah, we got everything covered. So yeah,
Sure, no
servers.
problem.
Yeah, there's servers, and then yeah, that's good for servers, right? Next is the database. So this is your question, right? So database architecture. So it's also important what your database architecture will be. So is it SQL or no SQL? Because it depends actually on what data you will be using. So is your data having too much relations, or is your data or are your data can be isolated into documents? So that's like the identification of whether you put it as an SQL if it's heavy on relationships, or no SQL if they have relationship but it's on a minimal, because you can still implement relationships in NoSQL via referencing. So yeah, that's one. And then also another thing is some practices in system architecture in MVPs, they actually have one server for the backend and for the database. Now, I actually don't I actually highly discourage that, because if we experience server downs, right? So that means if your system crash, knowing that your backend server and your database is only on one server instance, that could have a high risk of losing all your data. So really the best practice is to isolate your database into another cloud server. And this is where these providers come in. MongoDB Atlas or Google Cloud SQL, I'm not sure what's the counterpart for Azure and AWS. But yeah, the advantage of that is even though your backend server will crash, your data is still accessible. Because I've also experienced before that I cannot SSH to my server instance anymore. So all of my data wiped out. Also the disk for the server has been corrupted, so I cannot use that server anymore. So that's why it's very good to isolate our database to our backend server. But then there's an implication to that. The implication is you'll pay more. Why? Because you have additional resource, a cloud server dedicated for your database. Some people would argue that it's actually okay with the first approach because the data that they have are still test data. They're not handling real user data yet. So what they have is dummy data. So they can just they're not as scared of losing the data. They have no risk in that. So yeah, you have to weigh in these things you have to take these things into consideration when trying to identify the resources that you'll need for your application. So yeah, that's for the database. I hope I answered the question a while ago. So I'll proceed with the next one, front end frameworks. The very common ones, it's on JavaScript. But you can definitely build it on something else. But here's React, Angular, Vue, Svelte, and yeah, there are also other front end frameworks out there. So deploy for free. So yeah, they're actually like providers that they're actually services that allow you to deploy your front end for free or even your back end. So we have Netlify and Heroku. I think some of you are familiar with Heroku. So yeah, you can, because at the end of the day, when you compile your front end application, it's just going to give you static files, right? And you have to serve that on a proxy server like Nginx or SAMP to actually serve them on a server. So yeah, these are for the front end frameworks. And third-party services. For the email, you can have SendGrid or SendInBlue. These are the two most commonly used. For payment gateways, we have Stripe, PayPal. And if ever your app is more on navigation, you can have Maps and OpenStreetMap. So these are just some of the technologies that I know. Maybe you know more. So you can definitely use those things that you know. So again, cost. So going back to cost again, minimize subscription for MVP stage because we're testing waters here, right? Testing the market. So how do you minimize the cost when you're trying to build an MVP? So yeah, we have free trials and free credits from the major providers. So for Azure, you have like a $200 Azure credit, so you can experiment on the resources that they have. Same with Google Cloud, they have also $300 free credit, so you have to utilize that before you actually pay for your cloud instances. And then also AWS. And also when you're going to, like, for example, SendGrid, they have a quota for the email free for the free tier. They have quota for the email, but then that can be used for your MVP, right? Like, you don't really send out much emails when you're still at the initial stage of your product development, right? So you can take advantage of this free accounts, free tiers, free credits, free trials. So yeah, that's one key thing to take into consideration for MVPs. And step 5, once you have your architecture, you develop your features, you launch, and then you test. You identify the key issues. One key issue could be, oh, I noticed that if I actually have 25 users, my web page starts to crash. So that could be one issue. Another issue would be, I noticed that there is a delay in terms of like the API, or like when I try to request an information from the database, I noticed that there is like 5-second delay. So it could be like you can try to identify the issues that you've experiencing while doing the test. And then step 6 is of course redesign. So you address the key issue. Like for example, the one I've mentioned, that there's 5 seconds, that's called latency. So latency is actually how fast your data travels from one point to another point. So you experience a 5-second latency for your data. So that could one reason could be the location of your server. So probably you place your server in Singapore, whereas your users are actually located in America. So you imagine the distance from Singapore to America, the distance that your data has to travel from your user to your server to your database, back to your server, and back to your users. So that's one thing you have to consider, the location of your servers. So yeah, that could be one application for step 6, right? You calibrate your architecture, you redesign based on the key issues that you found on your testing phase. Okay, so this is the fairy tale story about the MVP being successful. So let's say that, because that's really the end goal here, right? Like your MVP will be successful. So you've done your iterations and you've got enough users. You are funded by a very well-known VC, and you're earning money, and your MVP is actually a success. So what's next for you? So the next step is actually, you need to accommodate more users, right? Because your MVP is successful already, you're catering to more users, to more functionalities. So you need to upgrade your resource, and or you could add system architecture components, and that's what we call scaling. So when your MVP is successful, eventually you have to scale. So for example, this is the MVP that we have, right? And this is assumably successful. Let's try to scale this up. This is the scaled system architecture of the e-commerce that we have. What I have here before, as you see, I only have one server, right? This is my development server. When I already scale, I already have a production server. That means my real data should be here. Real user data should be catered by my production server, and my test and dummy data will be handled by my development server. Because you already have lots of users, so you have to be very careful about the data also. And in here, in the database, you're actually catering to more data now. So probably you want to think that, oh, I might try to segregate the data, right? Like the media files, I probably want to use a bucket. So a bucket is actually a storage. In AWS, we have called S3. So that's actually a bucket. We also have Google Buckets. So this will help your database, have a lesser burden in storing many data types. So instead of like storing your PDF, your images in database, you could transfer them in the buckets. And then your database will only purely process information that is in JSON format, or whatever format, as long as it's text. So, and then you have email service. You can probably upgrade that to a higher tier. And then also for payment, because you're catering to more users now. And then sorry, going back, sorry, that's a spoiler. So now you're before, in your MVP, you're only restricted to web applications, right? But then now your user actually wants to have mobile applications, so you also have mobile apps for your e-commerce store. So yeah, you can also have that. So that's just an example of scaling up your architecture. You probably upgrade the capability of your resource, or you add more resources. So yeah, that's there. Yeah, product roadmap. So some people, some clients, and some visionaries or some people who want to develop products, they want to define this before you actually create a system architecture design. But for me, what I suggest is you create this after your product has passed through the MVP stage. Why? Because only after the MVP stage, you'll know that your product really has a potential. So after your product has been successful in the MVP stage, you create a product roadmap. So what is a product roadmap? So it's actually how your product will evolve through time. So let's say in 3 years, my app will actually have 5 servers already. Will have a desktop application instead of just having web and mobile app. So things like that. So things that you envision. So it's the product mission and vision. It's a high level visual summary of how your product will be in the next n number of years. So part 6, this is the last part of our discussion. So key concepts on scaling. These are actually deep, complex topics, and we encourage you to use your online resources for more research. So horizontal and vertical scaling. So I will just quickly give a description on what these are. So horizontal and there are actually 2 ways to scale your application. It's either horizontally or vertically. So if you want to scale your application horizontally, it means you increase the number of resources that you have in your architecture. Vertical scaling is the opposite. That means you retain the number of resources, but you upgrade them, the capability. For example, your virtual CPU has 4 cores, but you want to upgrade it to 8 cores. That's vertical scaling. If you want, if in your architecture you have 1 database, but you want to have 3 more databases, that's called horizontal scaling. Do you get the idea, the difference? So yeah, that's for that. Next is the load balancers. So typically your front end application, your front end part of a scalable website has a load balancer. So why do we need load balancer? There are times that in our application, we have so much traffic, right, that it causes our application to slow down and sometimes crash. So so load balancers allows a system to distribute the load evenly so that one server doesn't crash and take down the whole system. So to do so, of course, you have to build out a network of cloned servers. So you have many clones of your servers that all have essentially the same code and the same access to the same data. So next would be database denormalization and NoSQL. It's just basically restructuring your database based on your users behavior. So you are introduced to many types of data as you go along the way through your product development, and you want to cater more features. That means more types of data. So it's just rearranging and redesigning your database architecture. Next would be database partitioning or sharding. So it means you're just splitting your data across multiple machines while you're ensuring that you know what particular database shard holds a particular type of data. So for example, I want to put all of my user data into shard 1, and then I will put all the contracts, all the signatories of my user in shard 2. So those could be like that could be an example of the sharding process. Caching. So most of the time we have data that has been repeatedly used throughout our application, right? So what could be a better way than to minimize the communication of your app to the server, and that's through caching. That means you have a local storage within your application, and then when your user access that particular data, it doesn't go through a travel through the database just to retrieve that information. So that's called caching. It actually speeds up also some of the process. So you have to identify the data that's been constantly used, cache them, and then when the data is if the data is modifiable, then you cannot cache that because you need to also reflect that accordingly to your database. So you'll have a latest version of that particular data. So next would be asynchronous and processing queues. So this is where the job schedulers are shining. So for example, you want to schedule a marketing email every 12 a.m. every day. So when you're doing an MVP, you can just do that manually, right? Because there's really not a need to do that while you still have so little users. But then when your user base gets big, you want to automate some of the processes that you have on your application. So probably you can add a job scheduler for that, that will schedule, you will trigger an email to send this particular email template to all of the users. And another asynchronous process could be database backup. So you can also have that asynchronous process. You just have to put a schedule, what time and how frequent you want to have a backup of your database. Yeah, so those are just example of asynchronous processes. Last would be the network metrics. So most important thing you have to know when you're dealing with your architecture and your end servers is the bandwidth. So this is the maximum amount of data that can be transferred per unit of time. So it is expressed in bits per second or sometimes gigabytes per second, depending on how big your bandwidth is. Throughput. So throughput, whereas the bandwidth is the maximum data that can be transferred in unit time, throughput is actually the amount of data that's transferred. So how many megabytes or or gigabytes of data you have processed. And latency, I've already explained this one. It's actually the how long it takes the data to go from one end to another. So this is where your server needs to be in the same region where your users are so that it's faster. The traveling of data is faster. So I guess that's all I have to talk about the designing systems in MVP. I hope you've learned something today. And if you have questions, then let me know. And I'll give you back to our beautiful host, Miss Maitreyi. Uh, kindly take.
Thank you,
I'm giving the
Cleo.
floor to you now. Thank you. I'll share my screen. Wait. Okay. Stop share. Okay, there you
Cleo,
go.
but we have one question.
Go
Sorry,
ahead.
we have two questions. So
Yeah.
we have a question from Ben about the differences between a sharding and basket, which you had shared in one of your slides.
What's that? Basket and sharding?
Yes.
Okay. What's the difference between the basket? Oh, the basket, you mean the bucket? Okay. So the
Yes.
bucket is the database is actually the same resource. Like example, you have multiple database. That's called sharding. You're putting different data into a particular database shard. It's like your whole ecosystem of database has been broken down into pieces. While bucket is actually a storage. It's kind of confusing, right? Because databases also uses storage, but then bucket is a different resource than of a database. So bucket doesn't actually perform queries. It's just purely a storage. So in a database, you can perform database queries, but on storage, you just have to, just like your external hard drive. That's like the use of a bucket. So you can put there your media files or whatever you want to put for your application. I hope that answers your question.
Yes, Cleo. Thank you. So because we have different cloud providers now, which one would you prefer for quick prototyping? Is it
Oh,
AWS or Azure?
it really depends on the end of the day, the product. It depends on the product and what you want to make. But for quick prototyping, I suggest that you use free services like Heroku out there. Like Heroku, I've deployed when I was a student. I use Heroku a lot for like deploying my Node.js applications. So and it's also free. And for because as I mentioned, you have free credits, right, for AWS, Google Cloud, and for Azure. But then once these credits actually run out, you have to pay, because when you sign up for an account of these cloud server providers, they actually allow you to put their credit card. So it's better if you use Heroku for quick prototyping. And it really depends on what you mean by quick prototyping, because if you're going to make a complex app, let's say your app has many features, then the question there is not really about what server you're going to use, but you get my point, right? Like, it depends on what you will do, so that you will have a quick prototyping. But I suggest you use Heroku and the other counterparts of Heroku, instead of going for a full-blown cloud server environment like Azure, AWS, and Google Cloud. So yeah.
Thank you. So how do we usually calculate network metrics for designing systems?
Oh yeah, they actually, the in the cloud providers, they have system monitoring in there, so they will know at which part of the day your server crashed. So they have this crash analytics. They have monitoring also in their dashboard, so you can find that in either of the three. So they provide that, so you will know the bandwidth, the latency, and also the throughput. So also, if you're a web developer, you can also measure that with a browser. There's actually a tool, I forgot the tool, but when you do inspect element like the developer tools, you will know there the how your API performs, like how fast or how slow did you get the data from the API endpoint that you are using in your application. So yeah, those are like the ways to identify the what's that again, the network bandwidth, all those things.
Metrics.
Yeah, network metrics. Sorry.
True. No problem. So do you have any questions for us for the community? I mean, suggestions for
For
approaching. So we have a question about suggestions of how to approach user acquisition for MVP.
okay, you mean partnerships, right?
Yes,
Like,
partnership. Yes.
yeah, so I'm not sure how to yeah, I've done that actually with one email service. But actually, these partnerships, they will give you a customized plan. So you see there, like for example in SendGrid, right, they have the free tier, they have the middle tier, and then they have the most expensive tier. So when you approach the customer service of that particular third party service, you say, oh, we're a startup and we want to use your service. So if and then you do the negotiation there. So if we become successful, we'll really promote your service. So they will give you they will give you some perks or some other services that they don't provide in their usual pricing. So that's actually depending on how you negotiate with the partnership, so what you can give them and what they can give you. So yeah, so things like that. But usually in an MVP stage, you can't really do some partnerships, because you need to prove first that your product is really successful before the companies will actually partner with you. So what I really suggest is minimize the costing of your MVP. So yeah, I hope that answers your question.
Uh, Yes. And do we have any tips for mobile first MVPs?
Mobile first MVPs. Yes. So mobile first, what do you mean mobile first? Is it a web application, right? That but you're actually, are you suggesting PWAs, or you just want to have the responsive design for the web applications? Because if you want to have a mobile first MVP, I suggest you do a PWA. So that's progressive web apps. Instead of doing a full-blown mobile application, because mobile developers are very expensive, to be honest. It's better if you do it first in a web app. Then you just have to follow a certain dimension. In the Chrome developer tools, there's actually dimensions of mobile apps there that you can you can use as guide for your mobile design, responsive design. So yeah, and I suggest PWA, progressive web apps. You can Google that. That's very popular right now. And also one more thing, if you want to do MVP but in a mobile app, I suggest you do hybrid. React Native. What else? Ionic. So these are like front end frameworks. For example, React, but they actually are convertible to mobile applications. So in React Native, so you can also do that to minimize the cost. Because if you're developing mobile applications, you have to pay for Google Play Store, Apple developer account, and then when you launch it, you have to provide certificates for the app in order to be approved. So many things you need to do when you deploy a mobile application. So yeah, I think it's better if you do it on the web first, via responsive design, via PWA, or via hybrid front end app. Yeah.
Thank you so much, Cleo.
Yeah, no
It was
worries.
really helpful. And thank you everybody for your questions and making this event more successful today. Any more questions, if anybody has, you can put them in chat.
Yeah, if you have questions, don't be shy. You can also unmute and introduce yourself and ask the questions. So let us know. I will answer it to the best of my ability. If not, then if we have people who also know the answer in the audience, then they can also pitch in their ideas. We believe in interaction and interactivity. So this is not, it's two-way street. I learn, then you learn. We both learn from each other. So yeah. Any more questions? Let us see.
I'm going to
Oh, we
share
have.
my screen.
Yeah, go ahead.
So I think it's been helpful information till now with Cleo. So we have upcoming events also. You can follow our page, which is womenwhocode.com/cloud/events. We also have different communities with women who code only into Python and data science and blockchain. If you're interested in any one of them also, you can still join our community and let us know if you're interested to join them. We have next events coming up, which are Code Fly High, and it is going to be an interactive and practical session. I would request Jackie to join in.
Yep,
If you want to go ahead about the
sure.
events.
Sure, I can talk about the events. Yeah, Let Your Code Fly High is a series, so it'll be first of many events, and focus more towards kind of what Cleo has talked about, but more hands-on, building your own full stack application and deploying it to the cloud. And then the Firebase event is in March. For those of you who may or may not be familiar, Firebase is a database hosted on Google Cloud, provided by Google. So this is sort of an introduction to Firebase.
And I'm sorry, everybody, I missed introducing about Jackie. So Jackie is a leadership member with Women Who Code Cloud community, and she's been amazing and very supportive to everybody in the community. Like, you can anytime ping her and ask her anything about your professional or personal life. Everybody in the community is very helpful, and I would recommend everybody to join us and contribute, and you can grow together. Especially this is COVID time and we cannot go outside personally, so I think we should make use of it.
Thank you, Maitreyi.
So you can follow us on Women Who Code Cloud page. And lastly, thank you everybody for joining today's event and making it successful. We hope that it's been helpful to everybody. So just wishing a happy and very happy day. From wherever you're joining, wishing everybody a happy and great day ahead.
Thank you, everyone. Have a great day.